Okay, in the last video, we were considering this problem. If you have this relation where the tangent of some variable x over 2 is equal to the tangent times yet a different variable times the hyperbolic tangent of a different variable yet, so when these are multiplied together, it gives you the value of the tangent of x over 2. If this relation is true, then we're supposed to show that the tangent of x must be equal to the sine of 2a times the hyperbolic sine of 2b divided by 1 plus the cosine of 2a times the hyperbolic cosine of 2b. And in the last video, we had done some manipulations with a problem, and turns out that so far the numerator has fallen into place. Now this is what we had as the denominator being expressed as. So now we want to work with the denominator and see if we can get it into this form. And right off the bat, there's something here that draws our interest, and that's this. See, here we're supposed to have the cosine of 2a. Here we have a cosine squared a, and over here minus a sine squared a. And there's an identity there that the cosine squared a minus the sine squared a is the cosine of 2a. But we can't, there's nothing here that we can factor out yet, because this is being multiplied by a hyperbolic cosine squared of b. This is being multiplied by a hyperbolic sine squared of b. But here now I think is where we want to draw upon one of our basic identities. Remember that hyperbolic squared of b minus the hyperbolic sine squared of b equals 1. So this, the hyperbolic cosine squared b minus 1 would be the hyperbolic sine squared of b. So we can replace this with hyperbolic cosine squared b minus 1. So if we replace that with this and multiply through, let's see where this leads us to. So this will be equal to, the numerator stays the same, nothing changes up here. This is the same. 2 cosine squared a hyperbolic squared b minus 2 times the sine squared of a times this minus 2 times the sine squared of a times minus 1. That's plus 2 times the sine squared of a. Of course, this is all over. This is just one denominator here. Alright, now, here we can factor out this cosine squared b times 2. So this is now equal to, numerator stays the same, and we're going to have 2 times the hyperbolic squared of b times cosine squared a minus sine squared a. Plus this. And our numerator is the same. So this has an h in it. Okay, and this is the cosine of 2a. So let's rewrite this. Two times the cosine squared b times the cosine of 2a plus 2 times the sine squared of a. Okay, now let's see what we're supposed to have here. It says a cosine of 2a times the hyperbolic cosine of 2b. Here we have the hyperbolic squared of b. Now we have to think of other identities that we can draw upon. Remember, for the hyperbolic cosine of 2b, there's several of them that we derived in our introductory video. One of them, we can hope hyperbolic cosine of 2b, and we have the hyperbolic squared of b. So there's one that is 2 times hyperbolic squared of b minus 1. Like this. And so if we have this, that would be the hyperbolic cosine of 2b plus 1 would equal this. So let's see where that takes us to.